Good morning, everyone. Today, I want to discuss a problem on magnetostatics. In this problem, a magnetic vector potential is given and we have to calculate corresponding magnetic field. So, let us see the problem. Find the magnetic field corresponding to the vector potential, this where f is a constant vector and here r is the position vector and this is magnetic vector potential, and we have to calculate corresponding magnetic field. Here A equal to half times f cross r, where f is a constant vector and r is the position vector, plus 10 by r cube r vector. This is position vector and r is the magnitude of this r vector. So let us see the solution. We have B equal to curl of A. This is the relation between magnetic field and magnetic vector potential. Here B is the magnetic field and A is the magnetic vector potential. And the relation between them is this: B equal to del cross A del cross magnetic vector potential. And in previous video I discussed about it, the relation between magnetic field and magnetic vector potential. And this is a problem application of the definition of magnetic vector potential. I already made a video on magnetic vector potential and you can see it. So let us see the next step. In place of the position, in place of A, we can write this: A equal to half times f cross r plus 10 by r cube r vector. This is given in our problem and we can use in the definition of magnetic vector potential, or in this relation B equal to del cross A. So in place of A in this equation we use this, and we can easily write del cross half times f cross r plus 10 by r cube r vector. In next step we can write half times, because of half is a constant, so we can write it outside of this third bracket, and we can write del cross f cross r plus del cross 10 by r cube r vector. And next step, this is a very important step and we have to look it minutely. We write here half times only this term del cross f cross r, because of this term del cross 10 by r cube r, this term is 0, is equal to 0. How it is 0? Let us see. Since del cross 10 by r cube r equal to, we can write this. And how we can write this? We know from vector calculus that del operator is equivalent to r vector by r ddr, where r is the mod value of r vector, that is magnitude of r vector. So del operator, we know del operator, we write that I cap del del x plus j cap del del y plus k cap del del z, as well as it is true that del operator is equivalent to r vector by r ddr. These two expressions are equivalent, and from this expression we can derive the equation that del operator equal to I cap del del x plus j cap del del y plus k cap del del z. and vice versa. So this is very important in vector calculus, that del operator is equivalent to r vector by mod of r dd r mod. So we use here in place of del operator in this problem. So we can write r by r, r cross r by r ddr 10 by r cube. 10 by r cube is a scalar quantity, and this vector quantity we can write here r cross r. First r vector is due to del operator r vector, and second r vector is due to this r vector, and a cross product comes into play in between two vectors only. So we write here r vector cross r vector by r ddr of 10 by r cube, and this equal to 0 because of r vector cross r vector is 0. So equation 1 is this, that b equal to half of del cross f cross r. This is equation 1 because of this term is 0. And how it is 0 we already discussed here. Now let us see the next step. From vector identity we can write del cross f cross r. This del cross f cross r we can write from vector identity that f times del dot r minus f dot del operator times r. This expression we can write only when f is a constant vector, otherwise we cannot write these two terms. And let us see the next step. So from vector identity we can write this when r is a position vector and f is a constant vector. And next step we can write 3f because of del dot r is equal to 3. We know it from vector calculus, where del dot r equal to, we can write del del x I cap plus del del y. This is a mistake here. This is del del x I cap plus this was del del y j cap plus del del z k cap dot x I cap plus y j cap plus z k cap. This is position vector due to r vector. In place of r vector we can write this, and del del x plus del del y plus del del z. So we can easily write 1 plus 1 plus 1, that equal to 3. So del dot r is 3. From vector calculus we can easily write, and here is a mistake, and please pardon me. Del del x, and this will be del del y, and this will be del del z. And in next step, this is right also, del del x plus del del y and del del z, and this gives 3. So in first term we can write 3f, and from vector calculus if we calculate this term, then we get this will equal to f vector. This is a constant vector, and if we simplify it, then we can easily get 2f, and this equal to 2f. This is equation 2. Now let us see how this term will be equal to f. let us see. F dot del times r equal to, we can write fx. This is fx is the x component of f vector, and fy is the y component of f vector, and fz is the z component of f vector. And if we can write f dot del operator equal to fx del del x plus fy del del y plus fz del del z times r. That means times, we can write x I cap plus y j cap plus z k cap. And if we simplify it, we can easily write f of x I cap plus f of y j cap plus f z k cap, and this will equal to f vector. So this term will be equal to f vector. You may take a screenshot and you note down on your exercise book, and then you can realize it better. So if we use this here, then we get this term equal to 2f, and this is equation 2. Now if we use this equation 2 in equation 1, in place of del cross f cross r, if we use in place of del cross f cross r equal to 2f, that is, if we use equation 2 in equation 1, we can easily get the value of magnetic field. And so using equation 2 in equation 1, we get b equal to half of this. In place of this, we use 2f, which gives equation 2, and we can easily get b equal to f, which is a constant vector here. And this is the solution of the problem, that here A is the magnetic vector potential, and we have to calculate magnetic field, and we already calculate that magnetic field B equal to F. So thank you very much for watching this video. Thank you.